Hello everyone, welcome to AI Anytime channel. In this video, we are going to talk about lost in the middle issue of large language model, and also we'll develop a Streamlit application to see that how we can use the re-ranking features or the re-ranking capabilities, to solve this or mitigate this challenge of lost in the middle. So large language model, basically they ignore the context of the chunks, which are the middle of your long context. Now, if you're working with the RAG pipelines and if you are having a top documents, top k equals to 5, 6, 10, or n number of top k's, right? Most of the passages or the paragraphs or the chunks, whatever you call them, which are in the middle of your context, they are basically ignored by a language models. That's the problem that Stanford has identified, and they have a research paper on that. That's called Lost in the Middle: How Language Models Use Long Context. And that's a very common problem nowadays. And we'll see that how we can, use different libraries or the frameworks to solve this problem. I already have a couple of videos on the same topic, but in this video, it's going to be a bit different because now we're going to use a library called FlashRank. Okay, it's a library that has been developed by Prithviraj Damodaran. Is a great guy in the open source community. We're gonna see that how we're gonna use that library to build a Streamlit application where we're going to utilize different open source model to re-rank the retrievers or the re-rank the context. Now that's what we're going to do. So let's jump in and start our development. If you look at here on my screen, I have something called lost in the middle. How language model use long context. Okay, that's the research done by, you can see Stanford and the guys from California, Berkeley, and some of the other researchers from Samaya AI. Now, this is a paper. There are a lot of videos already available on lost in the middle. So theoretically, you can reach out to it. Now, how currently people are solving this problem? Okay, now this can be solved on two different level. You can do it yourself from scratch using cross encoder models. Okay, you have a lot of cross encoders model from sentence transformers. You can use that open source model to do it. Now that can also be solved through Weaviate re-ranking features that they provide these features of retriever, and you can see the same way. If you come down, they also explain that how are they solving this problem. So you can directly do it on the vector database level using Weaviate re-ranking features. If you are using Weaviate as a vector database, the other one is there are also a re-ranking capability available by Coher. So Coher has also a re-rank feature where you can use. Let me also show you that. Okay, so Coher has re-ranking feature as well that you can use to do that. You can see Coher re-rank. Okay, but these are all you have to pay money for them, by the way. Okay, because Coher is like a third party, and you have to pay it for the as a like an API call and etc. Right? That's the problem. Now that can also be solved on the orchestration framework level where you have used langchain or the llama index of the world. Now langchain already provides something called long context reorder. Basically, the re-ranking has been now named with langchain at least reorder, and you can see here it says lost in the middle, a problem with long context. No matter the architecture of your model, there is a substantial performance degradation when you include 10 plus retrieved documents. Now, if your retriever has n number of documents where n is greater than 5 or 6 or 10, then you see this problem that there exists. Now they are solving with something called long context reorder. Once you have the default retriever giving you the retrieved chunk, then you use this class of long context reorder to reorder that. Let me show you what I'm talking about. Now imagine this is how you get your page content, right, which is a Python list, and that's how langchain returns with a metadata is there. Now the reordering is done through this long context reorder, as you can find it out over here, and then you just transform documents. So a couple of lines of code, and then you do it. These are the ways that we are currently solving it using this, but there is a new library that Prithviraj Damodaran has created that's called FlashRank. This is a great guy, by the way. He has already earlier created something with grammar models that we have used it to create a couple of videos that you can find it out in my language model list playlist, and I'll also give the link in description. Now he has created something called FlashRank. It says ultra-lite and super fast Python library to add re-ranking to your existing search and retrieval pipeline. It is important to build a RAG pipeline with these capabilities, guys, because if you just do a self-query retriever having a single vector database and some prompt engineering, college students are doing it, by the way. So it's easy to build RAG, but I always say it's very difficult to build an optimized and a better RAG depending on the use case that you are working with. So And this is one of the part. You have re-ranking, you have LOTR, you have merge ranker, you have contextual compression, all part of it. Then you have round robin, then you have HID, hypothetical documents embedding. There are different ways to build a better RAG. Now, I also have created a video. There's something called metadata enrichment, where you enrich your metadata if you're performing a hybrid search with both sparse and dense vectors. So that's keep in the mind that if you're working for an organization, then these are the things that are required to build a better RAG. Okay. Now, this is the library we are going to use that helps you, with start with a model with having only 4 MB of model weights. That's a nano model, ultra light. No torch or transformer needed for this model. Particular model that we're going to use runs on CPU, boost the tiniest re-ranking model in the world, only 4 MB, and that's what we're going to look at in this video. Now, what I'm going to do is, let me start going into and develop our application. So for that, you can see I have my folder that's called Reranking Demo, and in this Reranking Demo, I will open this in VS Code I already have. And these are the only two requirements that you have to deal with. You need Streamlit and you need FlashRank. Okay, so just go ahead and create a requirements txt and install these dependencies. I already have installed them. Let me show how you can do it. I'm going to open in terminal, create a Python virtual environment. I already have that, but I will show how we can do that. -m-venv.venv. You can also create using virtual env if you want, depends on what kind of libraries and setups that you have. Just hit enter, it will create a virtual environment, and then just go and do cd.venv and scripts. If you are on Windows, if you are on Linux, you have to do bin not scripts, and then just do /activate if you are on PowerShell. If you are on Linux machine, you have to do source activate. Okay, so depending on that. Okay, now cd dot clean that. Let me open. So code is already open, and then how you would just install. So pip install -r requirements txt. This is how you install that. Now that is already done. Let's jump into code, guys. Let me just write. So we're gonna develop a Streamlit application. We'll also host that. So let me just create an app.py here, app.py, and in this, from FlashRank.ranker, it has a ranker module ranker.py, and from that ranker.py file, I'm gonna use couple of classes. First is import ranker, and the other is ranker re-rank request, by the way. Okay, so this is the class that I'm going to use, re-rank request, and then import Streamlit. If you don't know what Streamlit is, a Python library to build web apps faster. Okay, import Streamlit as st, and then import JSON. So let's get this. Now this is done. So I'm gonna just say, for example, print import successful or something. Import successfully. Now that is done. Now once you do that, if you have imported successfully, let's write a function. So define get result, and in the get result, I'm going to pass my query. So let's do that query. So I'm passing query, I'm passing passages, and then I'm passing choice, which is nothing but the model choice. Okay, because we'll have 2 or 3 different models choice there. Now I'm saying if choice equal nano, so we're going to have nano is small, medium, and large. These are going to be our choices. Okay, so if choice equal nano, I'll say ranker. Then just call the default ranker. By default, it is the nano model that you have. And then you have elif conditional, elif choice equal small. So for the small, the model will get changed. Then your ranker becomes, you define a ranker, and inside this, you're going to pass a model name. So let me just pass a model name. So model name is nothing, but here we're going to use ms. Let me just show the model name that we're going to use. So for the nano, you can see it by default. For the ranker model name, this is the model name that we are going to use. So let me just copy this thingy here. And that's a great library, guys. I'll tell you that why it's a great library that Prithviraj has created, and all credits to him. I'll tell you, once you are working with this rack pipeline, mainly, for example, now just understand, if you have to create a function app on Azure or a Lambda on AWS, you cannot work with these large models. Okay, that's why Nano is important, because it does not require torch or transformers. So even if it does not exceed more than 1 GB, of course you can zip it and upload on Lambda, but that if it goes more than 1 GB, that's a problem, because that's a problem with latency, that's a problem with the token cost, and a lot of other things that we'll talk about it. Now, the real problem is latency, because when you use Lambda, you expect to get output in a 2 or 3 or 4 seconds, right? Not more than that. And that's where Nano is helpful because it does not require those heavy dependencies or libraries that can help you build applications within less than a size of 1 GB together, right? Your entire application. Now, else if choice small, that is fine. Let me just copy this entire thingy. Copy, paste, and I also paste one more time here because we're gonna have four model. So is small, and after small, what we're going to do is medium, and then for this we're gonna have large. So we're gonna have four choices: nano, small, medium, and large. And then here we have rank T5 flan. Okay, so T5 is a model by Google, by the way. Rank T5 flan. This is the model that we're gonna have for this. And then we're gonna have for the large one, which is more than 150 MB size. That's a bit bigger in the model size. For that, we're gonna have we're not gonna have mini LM. We're going to have BERT model. So for that, let me write multi-BERT. So multi-BERT and L and then V2, or not LV2. Let me see. It's not LV2. It's L12. Okay, so let me just copy that. Fine. Now we have our choices of model. So what we're gonna do next is we're gonna have a re-rank request variable, and in this re-rank, I'm gonna use ranker request that takes your query and passages. So query equals query, query equals query, and then passages equals passages. And then you have your results. So results equals ranker dot re-rank, ranker dot re-rank, and then you pass the re-rank request and then just return the result. This is the function that you have to write. And then now let's start our Streamlit thingy. So st.set page config to set the page. I'm gonna have layout equals wide. That's basically a string. And then page title. So page title equals re-ranking or something like that. Re-ranking app. st.set page config. Now let's write a main function. Inside this main function, what I'm gonna have is, and let me just do if name equals main. And here I'm going to write all of my code logic to this. The first thing is st dot title, and in title I'm going to have re-ranking using FlashRank. Perfect. Now this is my title. Now let's have some sidebar. So st dot sidebar, and in sidebar I'm going to have or side dot write. Let's first write and then say according to the model size. You're gonna have a size sidebar menu to choose from. So let's do menu equals, and in the menu I'm gonna have nano, and then I'm gonna have a small, then I'm gonna have medium, and I'm gonna have large. So let's do that. So large. Now menu is fine. So after menu, what we're gonna have do is to have no choice. So let's do choice equals st dot sidebar dot selection dot select slider. It should be select box, and here you select your model. So let's call this choose, and then your menu. Fine. Now let's run this and see if you're getting the page. So for that, I'm gonna have Streamlit run app.py. And now you can see that we get this re-ranking using FlashRank. This is what we get, and we have now our choose option where you can select your models thingy and all. Now, I need some explainer here. I want to explain the app and some of the models. I already created some uh, markdown for that just to save some time. I will just copy it, but I'll explain that what I'm doing here. Now, after choice, what you have to do is you have to hit enter. Now you can see what I'm gonna having. I have a sidebar.info which explains the model options. The model options that we have for nano is small, medium, and large. So nano is 4 MB. So if you're working on a lambda kind of an or a function kind of an app, you can use this model, which is blazing fast model with competitive performance. But if you want small, which is the best ones, slightly slower with the best performance, ranking precision is there. Okay, now you can also use that. Now, slower model with the best zero shot performance is a medium one, but this is 110 MB. I recommend using nano or small, if you're working for Lambda kind of a thing, that helps you work with. Now, after that explanation, what we are also doing is we have an expander that is a collapsible accordion. Once you click on that, it opens an accordion. Now, in that accordion, what you can see, you can understand that why are we using FlashRank. So we have given some credit, and we are looking at that how the creator has created FlashRank, ultra-light and super fast Python library for search and retrieval re-ranking. You open LinkedIn on RAG pipeline, people are talking about re-ranking features, which is not new. We have been seeing it for the last few months, and we have used it. We have some of the videos as well on re-ranking. Now, we're just using FlashRank because now that is very helpful if you're working with app which has some latency problem, and that's where you can utilize this. Now, after that, let me just show that. Okay, so let me just refresh this guy here. Okay, rerun. And now once you rerun, you will see that model options have been explained because people should understand what these models are doing, nano and the small one. And once you click on that, you will find out that it says small, medium, large, and blah blah blah, right? Now, about flash re-rank, ultralight, and super fast Python library for search and retrieval re-ranking. That's what we are doing here. Now, what next I'm going to do is, let me just show that. Okay. Now the next is let's have a form. So what I'm going to do with ht.form, I'm going to have a form, and inside the form I will have a key, because you have to give a key to that form, because if you have multiple forms, the key will help you handle the session state, and that's why we are using key. Now key for this should be input or something like that. Okay, input underscore form or whatever. Okay, now this is my with ht.form, and here I'm going to have a query input. So query input equals ht.text area. I'm going to have a text area for this, and this is where we're going to have our query. So let's write query input. This is your query input, and after query input we're going to have a context input, and in context input let's do ht.text area context input, and after context input what we're going to do is submit button. Submit button equals ht.form submit button, and here I'm going to use let's have a label. So label equals to re-rank, and that is the label, guys, that we're going to use here. Now after that, once the button is submitted, what we're going to do is, let me just come down here. If submit button, if the button has already been pressed, what I'm going to do is, with let's have a spinner that will show the progress with ht.spinner, and let's write processing, and inside this we'll have our own all of our results. Let me just go a bit up. Okay, now with ht.spinner let's have a passages. So passages equals json.loads, because why we are doing json.loads here is, now once you use langchain as an orchestration framework or even other orchestration frameworks, once you retrieve the chunks or the top k document, the context or the page content, whatever, those are basically in form of a Python list. There's a Python list, and then there are different element of that list that can be keys, and within keys then you have IDs, then you have your the context, which is nothing but the page content, and then you have a metadata. So metadata is like optional, it's additional, but you will have an ID and you will have a page content. Okay, and then you have doc metadata. So basically it's a Python list, but once you take it from a Streamlit, you have to take that as a string, and that's why we are doing json.loads here. That will help us handle that in a Python list, that I can use it as a Python list. Now json.loads, and I'm going to pass my context input here. So let's do that. Context input is something that where you are passing your context. Now let's print in terminal to see if we are able to print it out. So passages, and I want to find it out if the passages is, what is the type of passages, if you get any error. So passages and then type of passages. Now this is done. Let's have a result variable, and in result we'll have our result. So I'm going to use get result function that we have here. If you can see, this is the function that we are going to use, get result. So let's use get result, and inside get result I'm going to pass query input, and after query input I'm passing passages, and after passages I'm passing choice. And in the choice after result I'm going to have ht.subheader, and in that subheader please find the re-ranked results below or something like that. Okay, re-ranked results below. And after subheader, what I'm going to do is ht.json. And in ht.json, I'm going to pass my result. We are done with our app, guys. Let me show what we have done quickly. So we have written a function that's get result, where we are utilizing different LLMs that are not LLMs, by the way. These are all models that are using open source models, the natural language or the LM based models, language models. And here we have that, and then we are using the ranker request, where we are passing our query and passages, and then we're just using ranker.re-rank. That's what we are doing here. The ranker is nothing but which holds your model. And after that, we have some page config for the Streamlit app. Then we have a title, we have a sidebar that helps you select from the menu. We have nano, small, medium, large. Then we have explainer that explains the model. That we have an expander that explains the app. And why are we using FlashRank? Some of its features like ultra-light, super fast, cost efficient, based on the state-of-the-art cross-encoders. Now, because if you use these heavy models like cross-encoders and all, you have to deploy on SageMaker model endpoint, or you have to run that within a container, and that will charge you a lot of money. That's why we are using this function. Of course, there can be a bit of trade-off, but I think that is fine, right? On a performance standpoint. Now, based on state-of-the-art cross-encoders, sleek models for efficiency, blah blah blah, right? That's the features of FlashRank. Then we have a form. Within the form, we have three things: one for the query, the other for the context input, and the other for the submit button. Okay. Now, you submit button, blah blah blah, with ht.spinner, passages, and print, and all of those things. Now, this is the app that we have written. Now, let's me first run it here. Whew. This will be out of that, guys. I written app inside. Now it's fine. Now once you rerun, you'll see about Flash rerank. We explain the app, and then the query input and the context input. These are the things that we have now. We have different models to select: nano, small, medium, large, and then we have query input and the context input. Re-ranking using Flash rank. Okay. Now let's come here and choose the example given on Flash Rerank by Prithvi Raj, and all the credit goes to this guy. Please star this repository, because I really liked it from an efficiency standpoint, because these are the development that we have to work on, and give kudos to the people, or the shout out to the developers who are creating. Now this is my context. Now if you look at here what we are doing, this is the context that we are giving with ID text metadata, basically an ID which is in a list, and then we are passing the list, and then we have a query how to speed up LLMs. Now once I give that, I will just do a re-rank and see. It says expecting delimiter. Okay, that has to be end. It says ranker request is not defined. Oh, ra ranker, not re-rank request, by the way. This has to be ranker request. Ranker request is the class. Excuse me. I don't know why again it take re-rank request. That has to be ranker request, or it has to be re-rank request. No, I think it's a re-rank request. So this has to be re-rank request. Yeah, this is to be re-rank, and now let's try it out. Now you can see, right? It's blazing fast. So once you use nano, which is like by selected by default, and you can find out that if your query is how to speed up LLMs. Now the fourth of the ID becomes the first one in your context. Now if I look at here the example, let me just make it a bit bigger so you can see that. Fourth ID is like this, and the first one is a parallel decoding, introduce look at decoding or something like that. And now if you look at the result, the question was how to speed up LLMs. Now the ranking says the re-ranked one, ever want to make your LLM inference go burr but got stuck at implementing speculative decoding and finding the suitable draft model? No more pain, thrill to unveil Medusa, a simple framework that removes the annoying draft model 2x speed up, right? It's talking about the speed up. Now it understand the re-ranked context. Now if you feed this to your LLM, because LLM looks at the first and the last context with more focus, with more attention. By the way, attention is the right word, because it ignores basically in the middle context. Now all of this might get ignored if you look at this. Now ID1 is something that was by default, this was the ID, but once we re-rank it, you will see this becomes the ID, which is ID4. And I think which is fantastic. Right now this is the nano one. If you go to small and just re-rank, you can see that again that's for the same answer, so we are getting the same answer. Now just imagine the performance is quite similar, the competitive with nano. And if you work with nano in a very latent focus or the latency focused application where you have to generate the responses quickly in some chatbots kind of a scenario, you should use nano for your retrieval, okay, for re-ranking features. Completely open source, you do not have to pay for coher re-rank. Of course there can be a bit of performance upgradation, but I'm okay with it, as I said. So we don't have to use coher re-rank or the Weaviate re-ranking features, because this might be available, through locally or cloud. You can see re-ranker coher and re-ranker transformers. It provides re-ranker transformers also for the open source. You can also use that. But what I'm trying to show you that with nano, with only 4 MB size of model, the tiniest re-ranking model, we are able to achieve this performance, which is fantastic. Now you can again use the same medium large model to do that, but nano and small is something that you should try it out. Now this is fantastic, and the code is available on my GitHub repository. You can find it out on my GitHub. If you go to AI anytime, you will find it out. Back to GitHub, guys, by the way. And you'll find it out over here in my profile, my repositories, and you will find it out over here. I think I make it, you can see the re-ranking Streamlit app. Now, what we can also do is Streamlit Cloud, okay, the community cloud. Let me sign in with it. Let's just sign in, and yeah, it will take a bit of time. So what I'm going to do is I'm going to deploy this application. So let's wait for it. Let's try deploying this on Streamlit Cloud, Community Cloud. We'll try it out. We'll see if we, I mean, this is how you can deploy it. So if you want to deploy Streamlit, because they give you 1 GB free. If your entire application size is less than 1 GB, and if it's an Streamlit, you can deploy on Streamlit Cloud for free. Let's do that. What you have to do, you have to come to share.streamlit.io. You have to sign in with your GitHub, and then you have to select your repository. You can see my repository name is Reranking Streamlit app. I'm going to deploy that, and I'm saying re-ranking for RAG. Re-ranking for rag.streamlit.app, and I'm going to say Streamlit app. My file name is app.py, and I'm saying deploy that. Once you do a deployment, you will see that it will start some oven or something. There's a very good UX. They do some socket programming to find out the status which is running in a container, and they will show you. You can see your app is in the oven now. Okay, now once you open manage app, you will see, let's see that if it's able to deploy it, or if it's giving some errors or something like that. But this is how you can deploy your Streamlit application for free if the size is less than 1 GB. Of course, you can go for premium if you want to pay money for the Streamlit cloud, and you can deploy it. But rather than that, I think Azure or AWS or GCP, the hyperscalers will be better to deploy if you're paying money, because then you can again better it in a managed way. Okay, in a very manageable way you can manage it. Now let's wait for, you can see it's installing the collected packages, and it's installing your packages, blah blah blah. And you can see Python dependencies, Streamlit is already installed, you know and all of those things. So it will take a bit of time, but you can track all the statuses here. You will see your status, and once your app is ready, they will launch the app. And now you can see it has launched our app. So it says re-ranking using FlashRank. Okay, about FlashRank, you can find it out over here. This is how it looks like. This is your nano, small, medium, large thingy. You are explaining it here, and you can do it in a better way. Of course, you can again change the color. Okay, in the go on the settings, in the system settings, you can make it dark, and you can see it's dark now. You can do that as well. Uh, let's do that. Okay, so I'm gonna ask the same question here. How to speed up LLMs, and let's see if this is working or not. So how to speed up LLMs, and we'll see if it gives any error. Maybe you can fix that and let us know in the comment box. Once you come here, put it re-ranking, and Nano is working fine. Nano, it didn't even take more than a second, to give it. It was something in milliseconds, which is fantastic. I just wanted to do that. Now you have a deployed app. Go ahead and use that app anywhere you want. And of course, for the capability showcase, if you're presenting to your clients, if you want to show it to your students that how re-ranking works, you can use this application as a reference and just so that how they can leverage FlashRank to build this kind of application. That's all for this video, guys. I just wanted to create a short video, not lengthy, to explain re-ranking. Just understand that LLMs have issues with lost in the middle. That issue will not be there in the near future. A lot of developments happening beyond the transformers architecture, like striped hyena. One of the example that have used different algorithm which is hybrid in nature, which flash FFT and a lot of other things. So what I'm saying is this problem will be solved automatically very soon from an LLM standpoint. But for now, once you are building on the RAG pipeline, you can use these kind of features. So you can use this as your reference and you can show it to people. It's not rocket science, it's easy to work on. So this GitHub, now you have the code with you. Now you can use this application. I will give the deployed link in the description. If you have any thoughts, feedbacks, please let me know in the comment box. You can also reach out to me through my social media channel. That is available on YouTube, it's a banner, and also the channel about us. If you like the content, please hit the like icon. If you're liking the content I'm creating, please share the videos and channel with your friends and peer. If you haven't subscribed the channel yet, please do subscribe the channel. That's all for this video, guys. Thank you so much for watching. See you in the next one.